Right, welcome to lesson 4, and we'll be dealing with finding the point of contact. So this is going to be the continuation from lesson 3. So basically here we're working with the equation of a straight line and the graph that is given to us, and to find the x and y coordinate, and also to find m. And we know that m is equals to the derivative of x with respect to derivative of y with respect to x. Now here they say the graph of f is equals to the given equation of x to the power 3 plus 3x squared minus 4x, and it has two tangents that are parallel to the line y minus 5x plus 7 equals to 0, right? Now it means that we have two tangents that we have to find, so meaning that we have to find 2 points of contact, meaning that we have to find 2 coordinates of x and y, and also we have to find the gradient, right? But now we've been given the line of y minus 5x plus 7 equals to 0. So this is going to be the equation of the straight line. So meaning that both of these tangents are parallel. If they are parallel, it means that they share the same gradient, right? So now you have to use what is given. So the equation we have y is equals to, so it's going to be y minus 5x plus 7 equals to 0. We have to write this in the form of y equals to mx plus c. So this is going to be 5x minus 7. And we know that from this equation, 5 is going to be our gradient. So meaning that the m is equals to 5, right? So you just have to arrange the given equation and have to write it in the form of y is equals to mx plus c. We know that x is x, our constant value of c is going to be minus 7, our gradient is going to be 5. So m is equals to 5. But remember that m is equals to the derivative of of f with respect to x. So now from our equation of f is equals to the following. So this is going to be the equation of f. So having to find the derivative of f, it means that we have 3x squared plus 6x minus 4, right? So now if you can check, we have m, which is 5, then we have the derivative of f, which is what? Which is 3x squared plus 6x minus 4. We know that m is equals to derivative of f equals to x. Then we have m, which is equals to 5. Then we have our derivative of f, which is 3x squared plus 6x minus 4. Then if you have to arrange this, you're going to have 3x squared plus 6x minus 4 transpose 5. We're going to have minus 5 is equals to 0. And from there, we have 3x squared plus 6x minus 9 is equals to 0. We have 3 here, which is our highest common factor. So it's going to be x squared plus, it's going to be 2x minus 3 is equals to 0, right? Therefore, we divide both sides by 3. It's going to give us 0. So we're going to factorize. So our factors is going to be x plus 3, and it's going to be x minus 1. Therefore, the given 2 points of those two tangents, one is going to be at minus 3 and the other one is going to be at 1, right? Remember, in order to find the equation of the tangents, we have to establish the x and y values. Now that we have established the x values and we have established the x values, we have to find the y values, right? Meaning that we're going to use the original equation. Our original equation is going to be f of what? F of x is equals to x to the power 3 plus 3x squared minus 4x. So meaning that we're going to first start by working out with x is equals to minus 3. So it means that if we substitute minus 3, we're going to get an answer of 12. So meaning that the first coordinate of the point of contact between the graph of f and one tangent line, it's going to be minus 3 is to 12. Then so this is f of minus 3. Then for f of 1, we're going to use the very same equation. We're just going to substitute x of 1 on the original equation to find y. We're going to have 1 to the power 3, 1 squared minus 4, 1. So this is going to give us an answer of 0. So meaning that our coordinates of x is 1, then y is going to be 0, right? So meaning that here y, so y is 12. When x is minus 3, y is 12. When x is 1, then y is going to be 0. Now let's find the equation of the two given points. So this is going to be point of contact number 1, then this is going to be point of contact number 2. So we just have to calculate the gradient of both, the equation of both. So we have y is equals to y1. Then we know that our gradient is 5. Here we're going to substitute which coordinate? The point of contact for negative 3 and 12. So this is negative 3 and 12. So we're just going to substitute. So y is going to be minus 12, 5. Then it's going to be x. Then we have what? Minus 3, which is going to be plus 3. Then our equation is going to be 5x plus 27 for the line that is parallel to the line of y equals to 5x minus 7. Then point of contact number 2, which is 1 is to 0, is going to be y minus y1. Gradient is 5. Then we have x1. Point of contact that we're going to use here is going to be 0. It's going to be 1 is to 0. We're just going to substitute. Then it's going to be y minus 0, 5x minus 1. Then the equation is going to be 5x minus 5. So meaning that these are the equations of the two lines which are parallel to the line of y minus 5x plus 7 equals to 0 on the graph what? On the graph of f, right? So meaning that these two lines are on the graph of f, and they are parallel to this line. And the fact that they are parallel means that they share the same gradient, right? So meaning that if you can check, we first have to rearrange the equation in the form of y equals to mx plus c, where m is equals to 5 and where m is equals to the derivative of f with respect to x. And we know that with this, we know that you can be able to find the derivative of f with respect to x. And after getting the derivative of f, the gradient is equals to the derivative of f. Then m is 5, which is given to us. Then f is 3x squared plus 6x minus 4. Then we just have to work it out and factorize and find the coordinates of x. After getting the coordinates of x, we substitute these coordinates of x on the original. So meaning that these two, we're going to substitute in f of x. So the first equation, which was this one, so the first coordinates, so meaning that for this one, we know that if we substitute 3 on the original equation, y is 12. If we substitute 1, our y value is what? Is 0. Then from there, after getting x and y and m, we substitute the first coordinate. First coordinate is negative 3 is to 12, where x is 3. Well, from negative 3 to 3, because you know that if it's negative multiplied by negative 3, is going to give us positive 3. You work it out, this is going to be the equation. Then for this one, we take the point of contact number 2, which is 1 is to 0. We substitute, then our equation is equals to y equals to 5x minus 5. So this is going to bring us to the end of the lesson 4. Then I'll post lesson number 5 after completion of lesson 1 up to 4.